Hello, everyone, and welcome to Metal 101, proudly presented by Ryerson. I'm Angie Gomez, and I'm thrilled to be your host for today's deep dive into the world of metal. If you're new to metal, curious about how it all works, or just looking to sharpen your knowledge, you're exactly in the right place. Think of this as your all-access pass to Metal University. Over the next 60 minutes, we're going to unpack the essentials in a way that's approachable, engaging, and actually useful for your day-to-day. We're going to explore the core characteristics of aluminum, carbon, and stainless steel, and help you build a stronger foundational understanding of how and when to use each. By the end of today, you'll be speaking metal with more confidence, clarity, and ease. So what can you look forward to with today's classes? Understanding the key differences between shapes, sizes, and applications, and what makes each grade unique. As you can see from the map on your screen, we've designed today like a university experience, complete with campus visits. Each stop is led by one of our expert professors, some of the brightest problem solvers in the supply chain world. And of course, this curriculum is powered by 180 plus years of Ryerson expertise, so you're in very good hands. Here's how today's class schedule is going to flow. We're going to spend about 20 minutes at each campus. First stop is carbon steel with Deb Mundweiler. Then we're going to head over to aluminum with Allie Jackson. And finally, we'll wrap up at the stainless campus where I'm going to be your instructor. After each segment, we'll have time for some live Q&A, so feel free to submit your questions through the Q&A button at the bottom of your screen anytime during the presentations, and we'll work through as many as we can in real time after each campus, as well as regrouping at the end for some additional. If we don't get to yours live, our team will follow up after the session. Also, today's session is being recorded, and you can follow up on YouTube afterwards. So enough from me. I just heard the first bell ring, which means we better get over to the Carbon campus with Professor Mundweiler.
Thank you, Professor Gomez. Hello, everyone. My name is Debbie Mundweiler. I am a Senior Product Manager of Carbon Long Products for Ryerson's Southern Region, and I'd like to welcome you to the Carbon portion of our Metals 101 class. Today, I will go over the topics of how steel is made and the different forms it comes in. So let's get started. What is steel? Steel is an alloy made up of iron and other elements. And I thought since fall is in the air and tailgating season is in full swing, I could use chili as an example in relation to carbon. For chili, you'll need to start with your tomato base, and then you could add your onions, your ground beef, tomatoes, and depending on where you're from, you may or may not add beans. Much like chili, carbon steel also has ingredients such as manganese, phosphorus, and sulfur. By adjusting those ingredients, it changes the steel properties just like when you tweak a chili recipe. It can change the flavor and texture. Is it going to be hot and spicy, or will it be mild? Will it be thin like soup broth or rich and hearty? Now let's discuss processed steel. The first stage of processed steel is hot rolled, often referred to as black or dry. Hot rolled black is used when the surface is not critical, but the integrity and the strength of steel is important. Another type of processed steel is pickled in oil, also known as P&O. During the process with P&O, the coil will go through an acid bath to remove any rust and mill scale. Once that process is complete, there is a coating of oil applied. This presents further corrosion. P&O is much cleaner and smoother than plain hot roll steel. Up next, you have also heard of cold rolled steel. The process of cold rolling reduces the steel to a thinner gauge. Gauge is the term we use to measure the thickness of the steel. This type of steel will have tighter tolerances, better surface finish, and uniformity. Following cold rolled steel is coated steel. As you know, also known as galvanized, galvanneal, and galvalume. This process is the next revolution in surface protection and performance. The zinc coating that is applied will enhance corrosion resistance and make the steel more aesthetically pleasing. Up next is a video to show how coated steel is processed.
Hey y'all, I'm a hot roll sheet of steel. I'm going to be made into an air duct. But wait, that means I need to become more corrosion resistant. Let's face it, this mill finish simply won't cut it. So I need a bath. What type of bath, you ask? Good question. You see, my level of corrosion resistance will depend on the type of coating I get. For instance, see the one labeled galvalume? It contains aluminum zinc alloy. That would definitely make me more corrosion resistant, not to mention heat resistant. My cousin, who's now a roof, got one of these baths. Or see galvanelled over there? That's a zinc iron alloy bath. That wouldn't make me as corrosion resistant as Galvalume. I remember my friend, who's now a door, took a galvanelled bath. The good news is my friend can be painted without further surface preparation. But it did create a gray matte appearance. No thank you. This sheet has got to shine. Okay, well here's my bath, galvanized. It's a zinc bath. How much zinc, you ask? Well, that depends on the specified coating weight. The higher the weight, the higher corrosion resistance. Me, I'm going all in. G90. That means 0.9 ounces of zinc coating applied per square foot on both sides. And that means when I'm done, you'll be able to weld me, form me, and if you treat me right, you'll even be able to paint me. Okay, time to hop in.
On this next slide, you'll see that once the steel is made, it gets worked and formed into different shapes. The most common are coil and plate. From a coil, we get sheets, and with each production step, certain features and benefits are added. The second most common is plate. Sheet and plate share similar origins, but each serves different needs. Plate is much thicker than sheet. For plate mill plate, referred to as PMP, the thickness starts at 3/16 of an inch and goes up to 6 inches, whereas coil mill plate, often referred to as CMP, begins at 3/16 of an inch and goes up to 1/2 inch and sometimes 3/4 of an inch. CMP is made from a cast slab and rolled as a coiled product. Plate is also wider than sheet. You can get plates in 84 inch, 96 inch, 120 inch, and even sometimes greater widths. So now that we've gone over how steel is made and its two most common forms, let's discuss the different grades of carbon steel. Steel grades can look confusing at first due to there being several numbers and letters. The main organization for defining steel grades in the United States is known as the American Society for Testing and Materials, referred to as ASTM. These designations will typically start with an A and be followed by a series of numbers and sometimes letters. The number after the A will represent key mechanical properties of the steel. For an example, let's talk about A36. The A represents it is steel, and the 36 represents 36,000 PSI min yield. Another example is A572 grade 50. 572 is the series designation, and the grade 50 represents 50,000 PSI min yield strength. Different grades of steel serve different purposes. Depending on the end use, the steel must meet certain strengths, flexibility, and hardness, or a combination of the three. Moving on, let's get into long products. When you hear about long products, you should think of bar, pipe, tube, and also angles, channels, and beams. Angles, channels, and beams are often thought of or referred to as structural products. These products are typically used in building and construction. Some of you may be wondering if there's any differences between pipe and tube. Yes, both are hollow, but to simplify things, tube holds things up, pipe holds things in. Examples of tubing could be grocery store ceilings and racking systems. Tubing also comes in several types and sizes, such as mechanical tubing and structural tubing. Mechanical tubing will go up to an 11-gauge thickness wall, whereas structural starts at 1/8 of an inch. Mechanical tubing is often used in recreation vehicles and solar power racks. A common grade for mechanical tubing is grade A513, and a structural tubing grade is A500. Structural tubing is often used for signs, towers, and exercise equipment. Uses for pipe could be irrigation system and plumbing systems. You can also get pipe in the A500 grade, often referred to as pipe-sized tubing. Another grade for pipe is A53. This grade is for pressure pipe. A53 pipe is pressure tested to see how much pressure it can withstand before bursting. The size measurement for each is a bit different as well. Tubing is normally OD by ID, that's your outside diameter by inside diameter, or OD wall. The wall is the thickness of the tube. An example would be 2-inch OD by 16 gauge wall. Pipe is measured by set schedule designations. For the wall thickness, an example would be 2-inch schedule 40. The higher the schedule, the thicker the wall. Let's move on to the solid side of long products. These products consist of bars and those structural shapes I mentioned previously. There are two groups of these long products, MBQ and SBQ. The first type is MBQ. MBQ stands for merchant bar quality. This is going to be the equivalent of the hot roll we discussed earlier. MBQ is going to be carbon steel only and only comes in the condition of hot rolled. There's not as much processing as with SBQ. These hot roll bars and structural products are going to be the plain nachos of the tailgate. Just a basket of chips and a little bit of cheese. Structural products are often found in buildings and bridges. SBQ stands for special bar quality. SBQ can come in carbon and alloy. This type of bar steps things up a bit. I would consider these the loaded nachos at the tailgate. These bars are going to have more ingredients and will be much more complex. SBQ can also be thermally processed, often known as annealed or quench and tempered. These bars are going to have much tighter tolerances, special chemistries, and enhanced mechanical properties. You will find these type of bars in highly specific applications and can also be referred to as engineered bar. SBQ requires precision and reliability that standard hot roll MBQ cannot meet. Some examples of uses would be shafts, sprockets, and gears. So remember, when speaking of carbon steel, it comes in several forms: sheet, plate, and long products, along with several different grades of steel and conditions depending on the intended end use. Also keep in mind, tube will hold things in and tube will hold things up and pipe will hold things in. I want to thank you for following along, and this concludes our lesson on carbon steel.
Awesome. Huge thank you to Deb for kicking us off with that lesson in steel. Did anyone else get really hungry during that presentation? No, just me? All right, well, we had some questions come in while Deb was talking, so let's get into some of those. Deb, let's see. Does the way a bar is made, hot rolled, cold finished, or turned and polished, affect its performance?
Yes, all three bars will have differences in surface finish strength, dimensional accuracy, and the internal stress within the bar.
All right. And then let's see here. What materials are most common for pipe, and how does the application, like fluid transport or structural use, affect the choice?
So in terms of carbon pipe, if there's going to be a transport of fluids such as hot water or gas, you'd want to use a pipe that is rated by how much pressure it can handle. For structural type situations like scaffolding framework, you would not need a pressure rated pipe.
All right, that makes sense. Awesome. Well, I'm sure we're going to bring you back at the end for some more questions, but I'll let you take a breather for now. So now that we built a solid foundation, it's time to lighten things up, literally. Welcome to the aluminum campus, where formability meets versatility, and we all get to meet Professor Jackson.
Good afternoon, everyone. Thank you for joining us today to learn a little bit more about the metals that Ryerson offers. I'm happy to tell you about aluminum, but first a little about me. My name's Allie Jackson. I'm your product manager for Aluminum for the South, which means I hold the relationship with the mills. I talk to your vendors, make sure you have the best price, and then we make sure your inventory is in the right place at the right time. But enough about me. Let's talk about aluminum. You're going to learn a handful of pieces today: what aluminum is, what all these numbers and tempers mean, how we're going to put those pieces together to make grades. We'll talk about the 9 finishes that aluminum can come in, and then we'll put all those pieces back together for you with some takeaways. So first and foremost, when you think about aluminum, if you're not super familiar with metal, your brain may go to aluminum cans, aluminum pots and pans, but aluminum is going to be in a lot of different places that you may not expect. For example, 7% of the moon's soil, so to speak, is aluminum. So you're, again, going to find it in all kinds of places, and you'll find that it's utilized in a lot of different applications. And why is that? Because aluminum is made of one of the most abundant elements on Earth, bauxite. Depending on what you add to that, copper, magnesium, manganese, silicone, zinc, it's going to change your grade and ultimately the way that your material acts in its end use. There's a handful of characteristics on why people like aluminum, and we'll come back to those in just a moment. There's 6 forms all together, just like Debbie. We have flat and long. But first, let's dig into the characteristics and the reasons why people like aluminum. So as mentioned, we have aluminum cans. It's probably where your brain goes if you're not super familiar with aluminum, which is good. Aluminum is very recyclable, so please recycle those cans. 70% of all aluminum that was created is still in the aluminum life cycle today. Cans in particular have a really short lifespan. From your grocery shelf all to recycling center and back onto the shelf, it's about 60 days from mill production and all of those processes. So very sustainable. We like that. Let's save the earth, please. The other pieces that we like aluminum for is the corrosion resistance. So back on the cans, that Coca-Cola that sits in the middle of your can, not corroding your material. But beyond that, we see aluminum utilized in other corrosion-resistant needs like marine uses, boat hulls, dock parts, things of that nature. It's also a really strong but lightweight material. So here we have a fancy sports car, and you'll find aluminum in all kinds of different parts of cars. Again, it's because it's strong, so it's going to withstand a lot of force, but it's lightweight, so your car can still go fast, fast, fast. And we also like it for its formability and machinability. So this car here has a few indents on the side of the vehicle, and sometimes you'll find like interesting indents in a hood. That's all formed. Your aluminum is formable. It's easy to work with. Along with that, machinability, like we talked about. It's not going to gum up your CNC machines. It's going to chip or kind of curly Q off. And again, thinking of sustainability, you can collect that scrap, recycle it. It goes back into the aluminum life cycle, and we continue on. Finally, our thermal conductivity or heat transfer. So like I mentioned earlier, pots and pans. Aluminum pots and pans are really good at conducting heat. But beyond that, we see aluminum utilized in other areas like radiators. We also see it used a lot in things like aerospace and aviation. Again, anything that's really got to withstand a lot of high heat, and still maintain its form at the end of the day. So we've looked at the reasons why people like aluminum. Let's look at a few of the forms that we can get aluminum in. So as mentioned earlier, we have 2 flat and 4 long. We look at our flat products, we have plate and sheet. Just like Debbie mentioned, the gauge or the thickness of your material is going to really determine whether you have plate or sheet. 1/4 inch is kind of the cutoff for aluminum, which can go one way or the other. For your flat products, you're going to see that used in a myriad of places. Marine, auto, house siding, roofs, aerospace, military uses, pots and pans, cans. We've talked about it all, and we'll talk about more. The long products, we have more categories here. Structural and pipe, bars, which are solid pieces of aluminum, extruded shapes, and tubing. Just like Debbie mentioned, pipes hold things in and tube hold things up. Your extruded shapes here for aluminum are very unique items. If you're out there trying to sell some aluminum, you want to look out for some customs. Custom extruded shapes, you have to have a specific die for that material. And once you get a stronghold on that business, it's tough to move it around. We see aluminum long used in a myriad of places as well. Signs, cars, HVAC, architectural, electrical uses, medical uses. Again, the utilization of aluminum runs deep, y'all. You can find it in just about anything. So we talked about why people like it and what kind of forms you can get aluminum in. Let's talk about the alloys next. So there's a couple different categories for aluminum, and the 2 different alloys are going to be non-heat treat and heat treat. The difference here is the way that that material is brought to strength. For your non-heat treat alloys, you'll have a cold worked material, so rolling or bending to bring that material up to strength. And here they are. We've got our 11,000 series, or excuse me, 1,000 series, 3,000 series, and 5,000 series. As these numbers increase, so does the strength of your material. Your 1,000 series most often will probably find 1,100 as your request. That's your most pure aluminum out there. It is very corrosion resistant and it conducts electricity and thermal heat very well. We see the 11,000 series, the 1,000 series used in electrical uses a good bit, radiators, heat exchangers. We'll also see it in power transmissions. And then again, it's good at that corrosion resistance. So you'll find it a lot in pressure vessel or chemical vessels. Continuing down the list, we've got our 3,000 series. You'll most often find inquiries for 3003 or 3105. This is a very workable product. It's a little bit stronger than your 1,000 series. So you'll see it in boats, aircrafts, cargos, trailers, a lot of things that need to kind of be formed and worked. But your 5,000 series is by far the most popular of your non-heat treat alloys here. 5052 is for sure going to come across your desk. You'll probably see some 5005, maybe some 5182, some 5086. That we'll dig deeper into what some of those numbers mean later. But your 5,000 series is your most popular because of all of its great qualities here. We see that used in automobiles, fuel tank signs, construction. Again, guys, just about anything you can think of, you can probably find some aluminum in. So those are our non-heat treat alloys. Let's look at our heat treat alloys. So as we mentioned, the difference between the two non-heat treat and heat treat alloys are the way that the material is brought to strength. Your non-heat treat are brought to strength through cold working. Your heat treat are heated to get to their final strength. Same idea with the non-heat treat alloys here. As these numbers increase, so does the strength of your material. 2,000, 6,000, 7,000 series, that 7,000 is going to be by far the strongest of all of the grades we've talked about so far. Your 2,000 series is probably going to be something in the 2024 family if you have any inquiries for that. It's generally a very application critical type of project. We see it used a lot for aerospace and aviation, and I don't know about y'all, but if I am flying somewhere, I want my plane to stay up where it's supposed to be, so we want to make sure that that material is correct. We also see 2000 series utilized in some precision hardware, fittings, things like that. Your most popular series here is going to be your 6000, and you'll see 6061 and 6063 called out a good bit for those. You can find 6000 series in almost everything we've already talked about, but most often I see it in transportation and construction. Now your 7000 series is pretty unique, guys. That's your strongest of all of your heat treat alloys here. That zinc in there that really brings that strength. We see that utilized in hydraulic presses. Also see it in a lot of motorsport, ATVs, dirt bikes, things like that have to go up and then withstand a lot of force as they come back down. If you're sort of digging around for some customers who use 7000, they're probably looking for 775 or 750. So if you get an inquiry for aluminum or you're trying to sell some aluminum and all you have is the grade, you're missing a big piece of the puzzle. We need the temper. So just like carbon, there's letters and numbers that come along with aluminum. And your aluminum temper is going to just basically be how your material performs in its end use. And we're going to watch a little video to give you some more info.
Welcome to the Aluminum Bistro, where choosing the right temper can make or break your order.
I'm ordering aluminum sheets, but I don't know what temper to choose. What do you recommend?
Let me walk you through our temper options. Each adds a special flavor to your aluminum, depending on how you plan to use it. For starters, we have the F temper, or as fabricated. This is your basic aluminum in its as rolled form. No frills, no extras. Perfect if you're planning to do some extra processing on your own.
Might need more refinement. Let's keep going.
Next, we have O for annealed. This temper makes your aluminum more flexible and ductile, ideal for when you need extra toughness. However, it's a little softer, so you might lose some strength.
Soft and flexible, but I'm looking for something stronger.
You might like our H temper, strain hardened. This adds more hardness and strength, perfect for when you need durability.
Stronger? That's more like it.
Or perhaps the T temper, thermally treated. We use heat and cooling to strengthen your aluminum to perfection, making it perfect for high-performance applications.
Sounds fancy, but maybe a bit too advanced for this order.
And finally, we have W for solution heat treated. Rarely the final dish, but it's a special process used to prepare your aluminum for further treatments.
I don't think I need that for now.
Oh, and before you finalize your order, both the H and T tempers come with their own set of numbers. These specify exactly how we apply the temper, giving you just the right balance of strength and flexibility.
Great! I think I know exactly what to choose now.
Whether it's flexibility, strength, or heat-treated perfection, there's a temper to suit every taste. Need help? Work with your Ryerson sales representative today.
Here we're looking at some of our most popular non-heat treat alloys. Your 3000 and your 5000. And like we talked about earlier, 3003 is a very popular one, and so is 5052. So the first number in these set of digits tells the mill what is your main alloying ingredient. The rest of the digits kind of tell them the rest of the recipe. But if you only have these 4-digit numbers, you're missing a piece of the puzzle. So let's put it all together with some 6061T6. Here we go. So as a reminder, your 6061 is your most popular heat treat alloy. And we have both pieces of the puzzle here. So your 6061 tells the mill what alloying ingredients to put in, and your T6 tells it kind of how to finish your material, so that those two pieces working together ultimately produce a product that is going to act or perform correctly at the end of the day in its end use. Okay, so we talked about how aluminum acts, why people like it. Let's talk a little bit about how it looks. So aluminum can come in 9 different finishes. We'll start with the mill finish because that's by far the easiest, and it's exactly what it sounds like. It's just however the mill finishes it. There's nothing fancy, no extra TLC that goes into it. That's going to be your most cost-effective of all of your aluminums. As we move down that first column, next is prime. And we have a couple of different finishes in prime. You can get exterior surface grade, fuel tank surface. All that means is that the mill's taking a little bit of extra TLC when they produce your material. Painted products are exactly what they sound like. You can get the top or bottom of your material painted. We have a couple of mills that paint in-house. We also leverage some outside processors, OSPs. Both sides of that puzzle love to boast that they can match any paint color out there. They're going to ask you 9 million questions to get there, but they can absolutely do it. And when we continue down this list, we see buffed as our last option. That's going to look very similar to this picture we have here on the screen, almost like a mirror. And there's different variations of buffed finish that you can get your material in. It's going to cost you if you need that nicer finish, but it's absolutely available out there. Then we move on to our anodizing. Anodizing changes the chemical finish or chemical makeup of your material. Essentially, it's just a protective layer on the aluminum. I like to use the example of pet tags, dog tags. That is an anodized product. It's got that coating on it. Sometimes it's blue or green. There's 2 different finishes you can get in aluminum. Pet tags is kind of the lesser of the finishes because who in the heck is lining up pet tags to make sure that they match perfectly? But if you do need your material to match perfectly, example, the side of the Superdome has anodized material on it. I don't know anyone who wants to pay for a building like the Superdome and have material up against a wall that doesn't match perfectly. You want it to be perfect, pleasing to the eye. You need a special anodizing finish. So then we look at our aluminum tread plate. If you're from the South, you're going to hear this called all kinds of different stuff. Tread plate, checker plate, toolbox plate, floor plate. But all of it, or diamond plate, all of it means the same. It's a pattern that is rolled on at the mill. Essentially, it adds extra traction to the material. We see it used most often, like we see here, on emergency vehicles. You can get different patterns. The diamonds on this are called buttons. You can get different button patterns and different heights. Then we have our stucco our embossed materials. This is another way of finishing the material. It's another rolled on type of finish. Stucco, diamond, and leather grain embossed are exactly what they sound like. Your stucco is going to look a little bit like stucco on the side of a house. Diamond looks very similar to the tread pattern. Leather grain, it's exactly what it sounds like. Looks a little bit like leather. And then finally, our perforated and expanded metals. We see that's more of like a graded type of product. I see it used in a lot of industrial uses, HVACs, ladders. Almost has like a graded kind of pattern on it. And next time you walk down a big scary ladder, you want to look down at it, it's probably perforated or expanded material. So we've talked about all the chemical makeup, the forms, the finishes. So let's put all of those pieces together on our takeaways here. So once again, aluminum is made out of bauxite. That's your most abundant element on Earth. You have 2 flat and 4 long plate sheet, pipe, bars, tubes, and customs. 3 non-heat treat alloys, your 1, 5, 3, and 5 series. And your 3 heat treat alloys, your 2, 6, and 7s. You have 5 aluminum temper options. Again, that's just the mechanical properties of your material and how they're going to act in the end use. And the 9 finishes that you can get aluminum in. So we've learned a lot today. I'm going to pass it back over to Professor Gomez.
That was awesome, Allie. That was truly a masterclass in aluminum. And I think you also get the award for rolling with the punches with some of those tech hiccups. So good job. We still got super valuable information there. But while we were talking, we had some good questions come in. So let's see. The first one is, if somebody's asking for stronger aluminum, would you typically guide them towards a different grade or a different temper or both?
Both is going to be the answer. So at the end of the day, the material that you need is going to be based on the end use of your application. So it's almost a tough one to answer without knowing the other pieces of the puzzle, but that's why we ask so many questions on supply chain, is to make sure that we're offering the right material. So as we discussed earlier, you've got your non-heat treat and your heat treat products, and then different tempers. So the end use is really going to drive what kind of different material we may be needing to order.
Got it. So the question to us would be a question back to.
That's it. What's the end use? If you give me that, I may be able to advise further.
Awesome. No, that's awesome. All right. So kind of a tie-in with that, but maybe a little more fine-tuned or condensed version of what grades are the best for corrosion resistance versus grades that are better for strength.
So again, I hate to revert back to the end use, but honestly, y'all, that is almost always the answer. But typically, you're going to want to find one of your aluminum grades that has a little more manganese and iron in it. If you're really focused on the corrosion resistance over strength, 5082, 5086 is probably your better bet. 6061 is corrosion resistant and a little bit stronger, but again, depending on the temper and the ultimate chemistry of the material, the end use is really going to drive what you need to be looking at to order.
Awesome. So yeah, so end use is a big part of aluminum then.
Big piece of the puzzle, and I'm always happy to help educate or get anyone connected with any METs at the mill if there's questions that I can't answer, because there's a lot that goes into it.
Sounds awesome. Perfect. Well, now's your turn to take a break. So aluminum gave us flexibility and speed, but now we're going to step into the metal that does it all and looks good doing it, probably like many of you out there. Welcome to the Stainless Campus. So to complete your studies today, we're going to check out the fascinating world of stainless steel. I'm Angie Gomez, and in addition to being your host today, I'm actually the West Coast product specialist for non-ferrous metal. So did you know that, like aluminum, stainless is infinitely recyclable? It does not lose quality every time it's melted. So most of the stainless you see today already contains about 60% recycled content. You can melt the same piece of stainless over 1,000 times and it will come out just as strong. So today we're actually going to dive in and explore what makes stainless steel different than the other materials. We're going to talk about its unique characteristics and the different grades, the various forms it takes, and the diverse finishes that give it its signature look. So we'll start right here. What is stainless steel? So stainless steel is an iron alloy that shares a foundation of iron and carbon, similar to carbon steel. However, for an alloy to be classified as stainless steel, the chemical makeup must be composed of at least 10.5% chromium and 1.2% carbon. Additionally, nickel and molybdenum, often called moly, are key elements found in the various types of stainless steel. So with 5 families of stainless steels available, each is differentiated by the alloying elements that are added. There are over 150 different stainless steel grades, each with their own chemical makeup, and we actually see new alloys being developed even today. Stainless steel is a versatile iron-based alloy known for its resistance to rust, corrosion, and staining, and due to its chromium content, it's continuously protected by a passive layer of chromium oxide that forms naturally on the surface when the metal comes in contact with air or water. This layer of chromium oxide allows the stainless to regenerate itself when scratched, thus it's corrosion resistant, highly durable, and less prone to rusting, even in moist and harsh environments. So stainless steel comes in many forms and shapes, just like the other materials we discussed today, so we're going to take a look at that. So when you buy stainless, we can get it as flat product, which includes our sheets, plates, and coils. Again, similar to the other items we've already seen today. We can also buy stainless bar, and that's going to come in similar shapes, which are round, square, hexagonal. And we can also have angles and structural shapes like I-beams. And then you're probably familiar, obviously, with pipe and tube, and we commonly order those as round, square, and rectangular. So now that you have some of the basics, we're actually going to jump a little deeper into the stainless grade families. So stainless steel is grouped into 5 main families. Each family has unique properties and applications, from kitchen utensils to medical equipment to industrial machinery and architectural structures. The classification of stainless steel into families is actually determined by the alloying elements that are added to that basic iron and carbon composition. And then that's going to then in turn create the grain structure and give it its properties. So 2 of those grain structures are austenitic and ferritic. You're probably more familiar with those, so we're going to start there. Austenitic stainless starts the journey, and they're typically seen as 2 and 3 series stainless grades, so 201, 304, 316, for example. And if you imagine the grain structure of these, you're going to want to imagine like a stack of marbles in a really tight cube. Very uniform, but also very flexible. You can see on the slide that these grades are highly weldable, ductile, and can resist high temperatures. If you see an L, for example, 304L, on a test report or stenciled on material you receive, that means it has a low carbon content, composing less than 0.03 of its overall structure, or composition, sorry. You will see austenitic metals used in your food containers, tanks, silos, and most general purpose and cosmetic applications. Ferritic stainlesses are next. So 409 and 430 are going to be your most common here. Ferritic stainlesses have low weldability, moderate ductility, and maintain a high temperature resistance. And to think about this grain structure, you're going to think about some empty boxes with a marble right in the middle of each one. Very strong and rigid, and not really great for forming and bending. So ferritic stainlesses contain more chromium than austenitic, no nickel, and adds in ferrite. The absence of nickel allows ferritic stainless to be more stable in pricing over time, and ferritics are magnetic, while austenitics are not because they contain austenite. Ferritics are typically used in appliances, car exhaust systems, and dishware. You probably find 430 as the metal that's inside your dishwasher, and 409 is probably part of your car muffler. So next, we're going to jump to some less common stainless grades. You can take a second here to look at your screen and see some of the differences between them. We do have access to these more specialty grades, and we can provide more in-depth information if you think your application might require them, but I'll touch on them briefly here. So martensitics, those are going to be used in cutlery and tools, and they contain a higher chromium than austenitics and no nickel. Duplexes are common in the oil and gas sector due to offering properties from both austenitic and ferritic grades, like being weldable, being highly formable, that kind of thing. You may have heard of 2205 duplex, probably one of the most common ones. Duplex actually gets its name because of its dual grain structure. It's composed of both the austenitic and the ferritic structures, and I've heard it kind of described as almost like it looks like threads, because we have some going up and down and some going across, so it almost looks like a stitching pattern if you look at it under like a microscope. Oil and drilling and chemical processing operations use duplex as it's stronger than 316 and better at corrosion resistance. Precipitation hardened, also known as pH, is actually a hardening process and less about the chemistry of the material. It's actually a heat treating technique that's used to increase the tensile strength of the material. These materials are typically found in aerospace and high-tech application like gears, valves, and other engine components. So kind of like Allie with her aerospace, when we're requesting those, we really want to make sure we know what it's being used on, so we make sure to get you the right stuff for its end application. So now we can transition to talk about the finishes stainless can have.
Are you looking to enhance the appearance and functionality of your metal products? Are you not sure which is the right match for you? Then let's play Meet the Metal Finishes! Today we're featuring stainless steel finishes. While a bit dull and non-reflective, this first finish likes industrial applications like tanks and conveyors. Meet number 1 hot rolled. This next finish is a smooth character. Non-reflective, this descaled finish is ideal for roofing applications. Meet 2D. If you need a more general finish, meet 2B. Also smooth, 2B is moderately reflective, ideal for cookware. Bright annealed is a mirror-like reflective finish, used in auto and appliance trim, surgical instruments, and more. Number 3 and 4 is often considered a final polished surface, providing moderate smoothness and reflectivity. It's time for the number 8 twins. Number 8 directional gives you visible fine lines for a traditional look. Number 8 non-directional is reflective with no visible lines, available in sheet form. Now, here are 2 special finishes. PFD stands for pit-free dairy. This ensures a pit-free surface for food, beverage, and pharmaceutical industries. Not to be overlooked is Super 4, a more advanced finish with a single-digit RA value. Not sure which finish to choose? Let Ryerson help find the best fit for your application.
So now that we know the flat finishes, we're going to pivot over to some bar finishes. And we're going to start again with the hot roll. So hot roll comes out of the mill, similar to how carbon bar is produced. It does not get any extra processing done at the mill. It's typically pretty dark and oily. It's going to have some scale on it, almost look like textured, if you will. The next finishes, we can talk about in kind of a group. And they're cold finish processes. So the first one we'll talk about is centerless ground. And that's ground to a very specific diameter. Its appearance after grinding will be pretty shiny and clean. Cold drawn is, it's actually going to be drawn through a die, and it's not exclusive to round bar, can be done for flat bar as well. And the finish can be dark or shiny, and the difference is there it's going to have no scale on it. Rough turn is pretty much just how it sounds, and we see this used mostly on large diameter bars. So the mill's going to rough turn it to a diameter within certain tolerances, and then it can be finished to a very specific size at your end user. TD, or turned, is exactly that. It's turned on a machine and ground down. Again, we see this used to achieve some pretty specific diameters with tight tolerances. And it's going to be pretty shiny after it's done, but not quite as shiny as TGP, which is turned, ground, and polished. So it starts the same as your turned material, but it does get some final processes that use abrasives to polish and buff to get a very shiny polished finish. So now we're going to just do a quick little recap on everything that we've covered today. So remember, stainless steel must consist of at least 10.5% chromium to be considered stainless. There are 5 families of stainless steels that each have their own chemistries and characteristics. Ryerson does offer a pit-free dairy finish, which can be used for food and dairy applications. And there are 6 flat finishes and 8 bar finishes that are used in stainless steel products. And now it's my turn to answer some of your questions. So I've got to look them over real quick, but let's see here. How does a mill achieve a higher finish in terms of RA so that it may be buffed to a mirror finish? All right, so RA is going to stand for roughness average. And this is the average between the peaks and valleys on the surface of the material, kind of like we were just talking about with kind of the scale, if you will. So the lower the RA, the smoother the surface. A number 4 is done typically using about 150 grit abrasive belt. That's used to sand down the steel to a smooth but not overly shiny surface. It's kind of like a satin finish, if you will. And there will be some visible grain going in that direction. For a number 8, which is what we consider a mirror finish, that polish is achieved by rubbing the material with gradually finer abrasives. So it's going to start kind of at the number 4, process. And then to finish the mirror, it's going to actually get some work done before, and it's going to get some pre-grinding to remove any imperfections off the surface. It's going to get that first hit of the abrasive, and then gradually finer abrasives are going to be used all the way down to a final buffing that makes it bright, smooth, and mirror-like. Let's see here. Is 316 or 304 more corrosion resistant? So your 316 is going to be more corrosion resistant than your 304, especially when we're talking about like harsh environments. So if you're working with chlorines, acids, things like that, because 316 contains more moly. And so while the chromium forms the primary oxide layer, by adding some extra moly in there, it's actually going to stabilize that protective layer kind of that forms on the top of the stainless when it comes into contact with those things. And so that's going to make it more resistant to that localized corrosion, especially again, when you're talking about harsh environments with chemicals and that kind of thing. So, all right, I'm going to pause there. We'll go back to questions here in a second, but that brings us to the end of our campus journeys. But before we can turn you loose into the world of metal, we have to make sure you paid attention during today's classes. So we put together a little pop quiz, and it should be showing up on your screen here shortly. There we go. All right, so click in your answers, read the questions. I'll read them out loud here quickly for you. Give your answers, and then I'll review the correct ones. So number 1 is, which of the following is a key property of aluminum? Is it, it's very heavy and magnetic? Is it rust easily? It's lightweight and corrosion resistant. Number 2, what makes stainless steel resistant to rust and corrosion? Is it the high carbon content? Is it the chromium content? Or is it the aluminum coating? And then number 3, what element primarily determines the hardness and strength of carbon steel? Is it the nickel? Is it the carbon? Or is it the zinc? So I'm going to give everyone here a moment. All right. Give you about 10 more seconds to lock in some answers before no cheating. All right. So answers to your pop quiz. So number 1, what is the following is the key property of aluminum? It's lightweight and corrosion resistance. Best of both worlds, right? More bang for your buck. What makes stainless steel resistant to rust and corrosion? That's going to be the chromium content, again, forming that chromium oxide layer. And then what element primarily determines the hardness and strength of carbon steel? And that's going to be the carbon itself, kind of that running theme throughout all of our materials, or at least the stainless and the carbon today. So hopefully you all passed with flying colors. So now we can move into kind of our final round of Q&A with all the professors. So let's see here. Let's kick it back. Let's see. Hey, Deb.
Hey.
What's the difference between mechanical tube and structural tube, and how would I know which one to use?
So mechanical tubing is going to be typically smaller and have a much thinner wall, whereas structural will be stronger. It's going to have a thicker wall. Depending on the end use, if you require something that will require more, if you require something that's going to need more support, you'd want to consider a structural tube.
Okay, perfect. Let's see here. Hey, Allie, what would you say are some of your most commonly sold aluminum grades here at Ryerson?
5052 by far. 6061 is really popular. 3003. That's probably our bread and butter there.
All right. Let's see here. Deb, why does DOM tube come in random length?
Okay, so DOM tube, DOM stands for drawn over mandrel. And the hot stock that will come in, the raw material, usually comes in different lengths. And then also the process where the material is drawn through a die, that can elongate the tube as well. So standard would be 17 to 24 inch lengths, and 17 to 24 foot lengths. You can get exact cut lengths, but there's usually an adder to that. And so there's added cost. So by going with random lengths, it's more cost effective, and it's just kind of how it comes off the mill as it's being produced.
All right, let's see here. I had a stainless one come across. Let's see. What's the best method to repair 304 stainless steel surface with a 4B finish when chemical corrosion has occurred? So we didn't really get into the 4B finish, and probably a little bit of a longer conversation there, but typically you first want to clean the area that had the corrosion. Typically we see people use like phosphoric acid, that kind of stuff. And then you're going to want to start sanding it, kind of like we talked about with when you get to a polish, right? You're going to want to use some kind of abrasive to break down where that corrosion is and get it back to kind of the original grain, which is again now going to allow some of that oxide to come to the surface and form that passive layer again. Let's see here. Allie, we use 6,000 series for building our docks, but we're looking for a solution with saline water. Do you have any suggestions?
Well, if you're really tied to the 6,000, if you could sub your grade, I would look at a 5,000 series, potentially 5083, 5086, maybe 5456, depending on how corrosion resistant you want it to be. But if you're stuck on the 6,000, I would maybe look at either a clad product, or which means like adding a different type of aluminum on the outside of your 6,000 series. So a more corrosion resistant, on almost like a sandwich. So your bread would be more corrosion resistant, and then your meat in the middle could be the 6,000. You could also look at like a marine power, like a powder coating that would help also with some of the marine corrosion if you really had to have the 6,000.
Perfect. All right, let's see. Someone just asked me if I can name all the 6 stainless finishes once more. So I'll run through them for you. So the first one's going to be the hot roll finish. So we see it called either number 1 or H-wrap, which is hot rolled, annealed, and pickled. Then we move into a 2D. So again, just as dull, but a little cleaner than our H-wrap. 2B are your most common, which is just, again, kind of slightly reflective. Then we've got our bright annealed, which is a annealing process to get that finish on there. We have number 3, number 4, super number 4, and number 8. So mostly number 3 and number 4, which you're going to see, and that's again done by the abrasives that's used to finish the material after it's processed. And then we have our pit-free dairy, which is kind of the super fine polish that allows it to be a true smooth finish used in food and dairy applications. There's also the bar, kind of mirrors the flat, but if you have any questions, we can answer those as well. Let's see here. Allie, did you say the heat treats are 1 through 5 series, or the 2 through 7?
Heat treat are going to be your 2,000, 6,000, and 7,000. It would be too easy if they just went in order, y'all. Your non-heat treat are your 1,000, 3,000, and 5,000.
All right, perfect. We had a question come in about 18.8 stainless. So 18.8 is super good for corrosion resistance and durability. So it's ideal for like kitchenware, cookware, food processing, medical instruments, stuff like that. We don't really get into a ton of that here at Ryerson. Again, we have access to a lot of these things, but it's not something you probably readily find on our shelves ready to go. Similar to, I just saw another question, does Ryerson stock 2205 duplex? Probably won't find it on many of our floors. I think we do stock it in certain locations, but if you need it, we can definitely get it and quote you, get you all the information on that. Deb, what do you think's kind of the most common carbon you see or that we sell here at Ryerson? Is there any particular items or A36, that kind of thing that
I would say any of the carbon sheet and plate is are big movers for us here at Ryerson when it comes to, and then just the other things that I discussed before, the hot roll bars, the MBQ, and then the SBQ. We sell, a lot of cold finish and alloy bar as well. And along with tubing, Ryerson, we have our own tube mill that we, produce our own tubing here as well.
Yeah, nice. So Allie and Debbie, I know you guys are both in the South region of Ryerson. I'm over in the West Coast. Do you guys see differences in your guys' commodities, like regionally? So are there things that maybe are more popular out here on the West Coast that either aren't where you all are or anything like that? Do you see just like differences in like the different markets, I guess, of kind of what items are sold out of your guys' commodities?
I would say every once in a while will get brought in on a quote for some like aircraft quality type situations that are needed. And that's from the West Coast. Typically we'll see things like that.
Okay. What about you, Allie?
It kind of runs the gambit. I think because our regions are so nice and large, we hit a lot of different types of business, but I think I probably see more marine than like the North would see, just given my relation to the Gulf.
Yeah. That's kind of similar to out here. Yeah, like if you're close to water, we'll get some different call outs. For me on like 316, right? So I'm on the West
Makes sense.
Coast, got the ocean right here. So if it's closer to the ocean, I see more 316 called out, where, more inland, not so much a requirement. So yeah, it's kind of interesting to learn those things as we navigate metal. So
That's right.
all right. Well, I think we're going to wrap it up here. Again, if we didn't get to your questions live, we will follow up with you after. So what you learned today is just the foundation. From here, Ryerson becomes your partner in helping connect product knowledge with application, pricing, and availability. One of the biggest advantages of working with Ryerson is that you're never navigating this alone. You have access to expertise, inventory, and a team who understands not just what the metal is, but why it matters and how to help you get the right choices for your customers and end users. So thank you all again for joining us for Metals 101, and a huge thank you to our professors today. We truly appreciate you spending time with us. If you'd like to continue learning or dive deeper into material selection and supply chain insights, don't forget to visit ryerson.com for resources, product support, and all your metal needs. I also want to give a huge shout out to our monthly Cup of Joe podcast. It is a must listen if you enjoy conversations like this and want to stay plugged into what's happening across the metal industry in a more conversational way. And if you're ready to take the next step after today, we do have Metals 102, where we actually move from the fundamentals to more of the fabrication side. So be sure to check that out as well. And on behalf of Ryerson, thank you for being here and investing in your knowledge. And until next time, stay curious and stay connected.